So now let's look at an example involving the generalized pigeonhole principle. So show how the generalized pigeonhole principle implies that in a group of 85 people, at least 4 must have the same last initial. So let's identify what our pigeons and holes are and our value of K. So here, M, N, our number of pigeons. N, well, there's 85 people, right? Our number of pigeon holes. So here, if you look back, I'm looking at them having the same last initial. So there are 26 different possible initials. So those would represent our pigeonholes. And then K here, you're trying to show that it has at least 4. So K would be 3. Because remember, the statement in the pigeonhole principle is K plus 1. So here's kind of the visual setup. Here's where I have my pigeons, or in this case, my people. So X1, I'll just use the labeling X1 for the first person, X2 for the second, and then the last one is X85. And then over here, you have your holes, which are the 26 different initials, last initials, so they could have A, B, C, all the way down to Z. And now let's check. Remember, we need to look at K times M. K times M, 3 times 26, that is 78, which is smaller than 85. So K times M is less than N. That means we can use the generalized pigeonhole principle now. So you're going to say by the generalized pigeonhole principle, some initial must be the image of at least K plus 1 people, right? But K was 3, so it would be 3 plus 1, or 4 people. So another way to say that is at least 4 people must have the same last initial. There are at least 4 people that went into the same hole, and the holes corresponded to their initials.